Hello, this is Dr. Numericals. I'm teaching here at IRFA Coaching Institute. I'm teaching physics here. Look, when we contacted our previous students, and they are not able to make it NEET and JEE, and we tried to know the reason, what was the reason that they were not able to qualify and they are not able to score much in physics. And when we tried to know the reason, and the reason came to be as there was lack of time, they were not able to solve the question in the prescribed time, which is usually 1 minute for the particular question. And to address this question, we have started here the series of trucs, and today we are solving the problems, mostly pulley problems, and we are calculating the tension using the truc. And I hope this will be very useful to candidates in supporting a lot, especially in JEE and NEET examinations. I hope that you'll be able to calculate the tension in any Newton's law of motion in any relevant problem in just a single sitter, and it will take you at the most 30 seconds to calculate the tension. But here, before calculating the tension, before introducing the technique, I would like to know you what this tension actually means. What is this tension? So, for example, let me take a block of mass M, which is hanged from ceiling through a string which is usually massless. Okay. Look, for example, here, this mass, it will exert electromagnetic force, and force, for example, take the cross section of area A. I'm dividing the string mentally into two parts. Okay, now the string is physically connected. My lower part is actually exerting the force. It's trying to pull the upper side downwards, the upper part downwards. And by virtue of Newton's law, the upper part also tries to pull. It's pulling the lower part upwards through electromagnetic force. And the common magnitude of this electromagnetic force, we call that the tension. So tension is actually a common magnitude of electromagnetic force. That's been experienced by the two different parts of the same string. And let me take now another cross section of the same string. For example, here the block is connected to the string, and the block is trying to pull the string, and it's exerting its weight, and that's acting downwards. It's trying to pull the string here downwards. But since it's connected to the string, and the string also exerts the upward force, and that will be equal and opposite to that, the force that this M is exerting rather. Yeah, and the common magnitude is what we call tension. Okay, the same happens here. If you look at here at the ceiling, the string is kind of pulling the ceiling downwards, and the ceiling is simultaneously pulling the string upwards by virtue of Newton's third law. And the common magnitude of these forces, which are equal and opposite in nature, we call that common force as tension. So what is actually the tension? Tension is actually a common magnitude of that very electromagnetic force. And so that's what we know about this tension. Now the question is, for whom I'm here, how to calculate the tension in just a single setup. To address that question, we are developed a truc here, and I think it's workable truc. The truc goes like this. A tension is equal to sigma in summation. We have to add, what we have to add is coefficient of tension. Coefficient of tension, and then we need to multiply with the acceleration due to gravity that we denote by G. Okay. And we are then dividing it by the summation of squares of coefficients of tension. Okay, and we divide that by the respective mass. Okay, we may not knowing yet what what is the coefficient of tension and what is this M here. To introduce that, I will teach you through some examples. We will be solving some examples which, by which it will be clear to you guys. Now, yes, now recall the trick for tension, and the tension reads T equal sigma, here means summation of coefficient of Ti. Ti means the tensions of different sections of the sand string that we will come to know when we will be solving the numericals. Okay, multiplied by G, which is actually the acceleration due to gravity, then divided by sigma of y in summation of y, summation of coefficients of Ti, and it's actually the squared divided by corresponding masses. Let me now solve some numericals so that you will get the feel of the truth. Okay, let's consider here a Carnot's machine. The two blocks of masses M1 and M2 are running over a pulley through some massless string, and whenever there will be the massless string, and the tension will remain same throughout. Now look here, and as teaching you tension earlier, that time we learned that this block of mass M2 is exerting the downwards force, the force of gravity, by its weight, and the string is pulling it upside with the tension, so the tension will be acting upwards here. Okay, now the same string is running over the pulley, so the tension will be same throughout, and the tension is actually trying to pull this block upwards so that it can rotate it intact. Now look here. What is the coefficient of T here? Tension. It's 1. Okay. What is the coefficient of tension here? It's 1. Now let's calculate it by truth. For example, so we have right here we've written out the formula tension equal to summation of coefficient of Ti and multiplied by T. So what is the coefficient here? It's 1. Okay. Plus what is the coefficient here? It's again 1. So 1 and multiplied by G divided by the sum of scales of the coefficients divided by the corresponding mass. Here, for example, it is 1 scale, the coefficient here is 1 divided by the mass and 2. Here. Plus the coefficient here, that is 1 scale divided by the mass and 1. Look here, you have to take the coefficients of tensions only to those places of the string while the masses will be connected. Okay, for example, I am taking the tension here and here, not here. Right. So what is the net value? It's 2G divided by 1 by M2 plus 1 by M1. So that's my answer. I solved the problem in just a second. So realize the beauty of our trick. Yes. Okay. Let me now solve another very problem. This was actually a single pulley problem, so we are now going to double pulley problem. For example, we are having 3 blocks here, masses M2 and M3 running over a pulley, and it's further connected to block of mass M1. Okay, and over a pulley, the string here is running over the pulley. Good. Now this mass will be acting downwards. It's a force that will be forced by what of its weight. Okay, and the string is trying to pull it up with force, and that we call as tension. So tension will be acting upwards. Same will happen here. Likewise. So it will be tension. Now look, as you may have understood through the three-body diagram, the tension, let its tension be T prime. Okay, T prime upside since it's balanced, so and 2 T's are acting down on the downward side, so my T prime ought to be equals to T, as you may have gone through three-body diagram. So what will be the tension here? Actually, it's 2T here. Okay, now the sand string is running over the pulley, and it's connected to the block of mass M1, so the tension here will be same 12, so it will be 2T here as well. Okay, let me now calculate the magnitude of this tension. Okay, using the stroke here, my tension equals summation of coefficients of tension. Look, what is the coefficient here of tension here? It's 1. Okay, what's here? It's 1. What's here? It's 2. Look, I will not take this coefficient into account because I have mentioned earlier that only those tensions need to be taken into account where the blocks of different masses will be connected. For example, it's here and coefficient here is 1. So let me take it into account. So it's 1. I will take the summation of coefficients of here. And what's the value here? It's 1. Okay. What's the value here? It is 2. Again, I am repeating that I will not take this into account because I am only taking those coefficients into account where the blocks will be connected. And multiply by G, its acceleration due to gravity on the trip. Okay, guys. Divide by, I will take the summation of square of the coefficients and I will divide by the corresponding masses where masses will be connected. For example, here the coefficient was 1 and the block M3 was connected. So I will take here, it's once again divided by M3. So M3 is the corresponding mass that corresponds to coefficient to 1 here. Okay. Let me take this block M2. What is the coefficient here? It's 1. So I will write once again and divide the nearest block that's connected there, that's M2. Good. Okay. Let me now take this block M1. What is the coefficient here? 2. So I have to write here 2 square because I'm running my sum runs so coefficients are square of the coefficients. So divided by mass M1. Right. So my tension is equal to 1 plus 1 plus 2, that's equal to 4G divided by 1 by M3. Good. Plus 1 by M2. Okay, plus 4 by M1. So that's my answer. There lies the beauty of the equation, beauty of the truth that we have developed. Yeah. Look, actually, this is not my own truth. I have not developed this truth. This I have learned while I was going through the faculty training program in Kota. So I must rather appreciate my teachers there. Yes. So look here, you are just calculating this whole problem, and if you will be going through the conventional method, it will take a lot of time actually, and you will not be able to solve it in just 1 minute, which is prescribed during your NEET examination or day examination. So we need something different. We need something. There must be some truth to solve the numericals. By which you can solve, you will actually save a lot of time. So okay, this solves the problem. Now let me add one more pulley so we can solve another problem. I have 3 masses, but we are having now 3 pulleys. Look here, at this type problem. Mass M1 is connected here. It's running for the pulley. So that will be pulley A, that will be pulley B, that will be pulley C. Mass M1 is running over the pulley through a string. Okay, and it's further connected to pulley B, and there hangs up the mass M2. Okay, and we have another pulley C, and the mass M3 is connected here. It's actually a same string. It's single string. Okay, single string runs over the pulleys. Look here. Now this M1 is acting. It's weighted downwards, and now since it's connected to string, so the tension will be acting upwards. It's tension actually there, which is holding it up. Okay, now the same tension is here, it's same string, so tension will be here. Okay, the tension will be here, the tension will be here. But look here, what? As mentioned in our earlier case, just if you'll be having some three-body diagram, look here, it's TT, it will be 2T here. Let me make you, let's remember this thing. And now there will be pulley, and the string will be like this. Just right, if tension will be here will be 2T. You should always remember this, so you don't need to calculate anything. Just put it here, 2T, so you can write it in just a single go. And when you practice more and more problems, you can remember it in just you can do it in just 2 seconds. Okay, guys, look now, I will calculate come back to the tension. And what is that equals? For example, the coefficient here is 1 here, plus what is the coefficient here? It's 2 here, plus what is the coefficient here? 1 here. Look, I'll take only those coefficients. I'll not take this coefficient, not take this coefficient. I'm only taking those coefficients where these masses are actually connected. For example, I'm taking the coefficient here because M1 is connected here. Okay. I'm taking the coefficient here, that's 2 because M2 is connected there. Okay. And it's also acting a force. I'm taking the coefficient of T and my tension is acting a force here. So because M3 is connected, I'm not taking these coefficients into account. That means both is having 1 as the coefficient, corresponding coefficients, but look, I'm not taking these coefficients into account because I mentioned earlier and I repeat once again that only those coefficients need to be taken into account where the blocks will be connected. Okay. And multiplied by G from 2 is acceleration to gravity. Now I'm taking scales of these coefficients and it's 1 here. Okay, 1 square divided by mass that is connected there. Okay, now I will take coefficient square of this coefficient divided by this mass that is connected there. So it's 2 square divided by M2. Pulse 1 is here, so it's 1 square divided by M1, that's equal to 4G divided by 1 by M1 pulse 4 by M2 plus 1 by M1. Right, guys? Okay. So these are problems actually. Look, it would take actually a lot of time to solve this problem, but look here, we have solved it in just a single setup, and I don't think it will take a lot of time. It will take more than half of a minute. Now, let's take something very different. I'll be taking now the different case. Let's have a test. Yes, for example, we are having now 2 blocks, okay? First M1 and M2. M2 is hanging there, okay? And it's connected through M1 through a single side string. And the 2 is massless. But look here, M1 lies on the floor. Okay? Floor of the city. Look here. This will be exerting force, weight, its weight, that will be M2, G, that will be acting downwards, okay, but the tension is holding it upwards, okay, that's holding it in track, and coming back to that force is called tension. Okay, guys, look here, so it will be tension here, but look here, before applying this equation, let me say that this has, what is the horizontal component of acceleration due to gravity here? It is 0 here. So horizontal component of acceleration is 0 here. So I don't need to take into account this very coefficient in my numerator because G for that will be equal to 0. So let me calculate its tension, for example. Using the same coefficient of Ti. What is the value of Ti here? Coefficient of T, that's 1. Okay, 1 plus. Okay. It's 1 plus coefficient of this multiplied by, it's actually multiplied by 0, so that will be 0. I won't take this coefficient into account. The reason is only that the horizontal component of acceleration due to gravity is 0. Okay. So it will be 1 into G divided by 1 by M2 plus 1 by M1. Look, for here, the G was 0, my G prime, the effective acceleration due to gravity was 0. So I'm not taking that term into account in my numerator. So the acceleration is 1 by M2 plus 1 by M1. So my problem is solved. Look, you need to be very careful. I'm only taking the G whenever my acceleration due to gravity or any acceleration, and that's in the direction of this tension. And when it will be inclined at some angle, I will take that component of acceleration due to gravity. But my component, horizontal component here, that's obviously 0 because the sine is, it's assigned to 0. Yes, now I will take the example 9 of chapter number 5 of NLM of Barcelona. Look here. The question here is like this, okay, and you are calculating actually acceleration here. Now I will computing here the tension using the group, and from tension I can also calculate the acceleration. I will show you how. Okay, and just when you will be opening your book and you will see the example, you note the difference here, how much time it's taking using the conventional method, and how beautiful this stroke is, how much time it's actually saving. Look here. Now we will follow the same rule. What is the tension here? Okay, T, let it be T. Let it be T, it's single string. So what it will be here? It's 2T. Look here. So it's same string right here. So it will be same 2T. Look. Okay, so what will be my tension? My tension will be, I have to sum all the coefficients. What is the coefficient here? It's 1. Okay. What's the coefficient here? It's again 1. Look here. The coefficient was 2, but it's like fixed on the floor, and the horizontal component of acceleration, the component of acceleration along tension is 0. Acceleration due to gravity is 0. So I would take that coefficient into account. So I will only take two coefficients. This, the coefficient of M3 and the coefficient of M2. And I won't take that coefficient, the coefficient 2 here. Because the horizontal component of acceleration due to gravity is 0, that vanishes here. So my only two coefficients here survive, that's this and this. So 1 plus 1 multiplied by g divided by, but when taking in the denominator case, I'll take that coefficient as well into effect, because I don't need to write acceleration due to gravity in my denominator. So what is the coefficient here? It's 1 divided by the corresponding mass, that's 1 by m3. Right? Yeah. Here it's 1 by m2. It's actually 1 square by m1, 1 square, because we're summing both the scales of coefficients of the tensions, and we are dividing them by corresponding masses. And so, what is the coefficient here? It's 2, and 2 square, 2 plus 2 to cover here, that means, sorry, it's 4. 2 square means 4. Divided by m1. So, what my tension comes equal to? That's 2g divided by 1 by m3 plus 1 by m2 plus 4 by m1. Look, this is how you compute the tension in that very problem. But there in SCR, actually you are assigned the job to calculate the acceleration of the block m1. Look, I can calculate the force 2T is acting on the block of mass m1, and it's that very tension force that's creating here this acceleration. And so now you know the formula, Newton's law, second law, F equal to ma. But what is the force here? It's 2T. Good. So, and what's the mass here? It's m1. Okay. And let the acceleration be a, which I have to calculate how much acceleration. So my a is actually 2T divided by m1. So I have calculated the tension. So I use the value. I'm done. I've calculated the example I write here. So my acceleration is 2t. 2 into 2 means 4g. Right? Divided by, it's actually m1. So I can write m1, it's 1 by m3 plus 1 by m2. Okay. Plus I can write 4. That's my acceleration. I can also take this. Look what what has done there, has brought this 4 down, so has wrote it like this: g divided by m1 divided by 4. He has brought that 4 from numerator to denominator. Round goes like 1 by m3 plus 1 by m2 plus this divided by 4, that's 1. Go and check the HCR example 9 and see how much difficulty it's real. So we have done just in just a single minute. We have calculated acceleration due to gravity just a single shot. Okay. Hello guys, today I think this is enough, but let me suggest to you something. Actually, I would recommend you to solve this HCR. You should also be knowing the conventional method. You should not forget about that conventional method. But at the same time, to qualify to crack any entrance examination, you are usually assigned very less time for a single object, and you need to solve that in just 1 minute. So for that entrance examination, I think this is a very beautiful tool, and we have actually started a lot of series and tricks. We'll be bringing a lot of tricks for you guys, and but I would recommend you to go through HCR for JE examination. HCR just say that's a bad book. Whosoever studies HCR solves the numericals exercise, I don't think anybody will stop him from cracking JE examination. And I think that's for good for as well for this advanced level. And yeah, I'll also recommend this for NEET aspirants. For NEET aspirants, it's a little bit tough for those guys because they don't actually have that much of mathematical capabilities. But still, using these tricks, they can just follow our videos. We'll be giving them the right tricks, and with the help of the tricks, I think it will be very useful for NEET aspirants as well. So, thank you.